So, a little dark in here. That's better. Okay, today I'm going to move on to this question from, it's also on Leetcode. I'm solving them now in Leetcode. For a reason. The reason being, I found this plugin on NeoVim, where I could solve Leetcode questions through my terminal, and I thought that was very interesting. So this is what it looks like. I could solve them from here. I could run the test and then submit, and then go update on my Leetcode account. I still use Leetcode structure. I haven't really played around much with the plugins lists or anything like that. I just kind of go to Leetcode, look at the question under, for example, binary search, and then I come on here and I look up the question from Leetcode, and then I just solve it through here. But I still grab my questions from Leetcode. We'll see how long I do this, because I don't really like it. Yeah, I don't really like it. Like, the errors won't go away. I think this is like some external library. Let's see what happens if I comment it out. Or include detector. That solved that? Oh, it did. Look at that. Okay. I don't know if it'll allow me to submit without this. We'll see. But it's still kind of like new to me, and I think that's the only thing I don't like about it. Another thing I don't like is I'm using Ghosty. I don't know if you can do tabs. So far I've been doing new windows, and I've been doing this thing in the past couple of streams where I'm just like, I have this folder called Leetcode questions, or it's just called Leetcode, but I have questions in there, and I essentially create the functions, and I have a main where I put all the test cases on main and run it through this one file. I kind of like that a little bit because I could print stuff out. It's a lot more clear to me. I haven't tried this in Leetcode, like in the terminal or even here, to print stuff out and see if, I mean, the test cases would fail, obviously, because it's not a real submission if I'm printing stuff out. But I don't know. I just like having a clear file, playing around with the inputs themselves, and then I can print out specific, like, this is the input, this is the expected output, yada yada, whatever. So anyways, tabs. I don't know if I could do tabs in Ghosty. I haven't looked it up. I'm assuming you might be able to. There's a lot of terminal emulators where you could do tabs. It's so common. It would be kind of weird that you couldn't do tabs. I'm curious. I'm gonna look it up. Let me see. Okay, Command W to close them. And P. No, I don't think you can do it. Let me see. Yeah, no, this, okay, it just did a new tab, or a new window. This isn't even a tab. I don't know why you call it that. Okay, so there's some other forks. I tried iTerm2. I like that one a lot. I don't even know why I switched. I think I've seen some people on Reddit and on YouTube talking about Ghosty, and I am not really like this terminal. I'm not really like a terminal guy. Like I like using it from here, like here and there. But I won't die on a hill on a terminal. So it's just like, okay, I'll try it. And so I've been using Ghosty, but I used iTerm2 for some time. And I'll jump again, really, if I find something more interesting. There's really only so much you can do with terminals. I mean, like, I feel like with terminals, like the use case that some people fall into where they're like, oh, this terminal does this other thing better. I have not fallen into that category for anything that I do, just because I don't use the terminal like that. So it's like, okay, it's nice that it renders a little faster, I guess. But, you know, using iTerm2 is not like I don't know, like the delay is like, whatever. I'm not gonna be like, can't switch to anything else because this is such an important feature. I feel like that's with anything though, right? Or maybe I feel like maybe some people are more committed than that. I'm just like, I'm just not. So, okay, wait. I don't need this right now. You can do vertical tabs. Can you do like horizontal tabs? Like a fork or something. Hold up. What is this? I don't think I have this. Yeah, no, because it's like a config file, right? I don't even know how they got that. It looks like a iTerm. Nice. Features. Whatever. sidetracked. Anyways, yeah, let's try to do this one. Probably easier to read on here, but I am gonna try to read it through this terminal. Let's resize this to make it readable. I think probably here. Okay. Okay, so it's number 153 on Leetcode. Finding minimum in rotated sorted array. This is hard to read. It's hard to look at, not read. We're gonna look at it through here. Let's see. So, yeah, you have the vector. Ordered in ascending order is rotated between 1 and n. Wait, what? How's it doing that? Wait, so once you rotate it, you have to set it in order in ascending. Like you have to set it in ascending order. Is that what it's saying? Doesn't make sense because it would always add. I don't think that's right. That's right. Okay, so I'm looking at this example. I'm gonna zoom in. I'm zooming in on the wrong thing. So nums in ascending order, right? You rotate it 4 times. Oh, I think I get it. Let's see. 1, 2, 4. Okay, the rotation is just like I don't know what I thought with rotation. I mean, I thought with rotation it was like I'm doing something with my hands. You're doing this. This is what I thought with rotation. Like you're essentially flipping them, right? Like a pancake. You're just like, that's what I thought. Rotation. Like clockwise. I guess it makes more sense if you link the beginning with the end and you start moving the numbers clockwise, then you kind of, that makes more sense. Okay. That's not what I was thinking though, but anyways, let's see. So rotating. Okay, so somehow we have to link the end, the beginning. I'm trying to figure out how this is binary search. It says, notice that rotating an array one time results in what does that even mean? So they're just saying if you rotate it once, you're essentially moving you're moving all values up by 1, but the last one goes to the front. That's what they're saying. Okay, then they continue to say, given the sorted rotated array of unique elements, return the minimum element of this array. Wait, I'm so confused by this question. Why would they want you to return the minimum element? Wouldn't the minimum element exist in the original at the first position? So it doesn't really matter if you rotate it, you can just grab that number? Or what do they mean by minimum element of this array? I mean, how would, okay. Okay, yeah, let's look at the examples. Wait, it's not sorted though. Didn't they say it was gonna be sorted? Suppose an array of length n, sorted in ascending order. I mean, this is not sorted, so I'm kind of confused by why they would say that. Do we have to sort it? Put 1. Okay, they found 1 in the array. That's. Wait, what do you? Okay, it's already sorted. We have to figure out how many rotations until it's sorted correctly. So, you know, in the original array, it's not sorted. But if we start rotating the array, eventually 1, so I think 2 rotations, right? 2 rotations, we'll put 1 at the beginning, and then 5 at the end. And then we can find the minimum value. It's already sorted. It's just not in the right position. Okay, if you rotate it 3 times. Wait, why 3? So from 1 to the end, isn't that 1 jump? And then 2, like 1 more jump, and you get 1 to be in position 0? Why does it say 3 rotations? Okay, that one's kind of weird. This one says the original array, and it was rotated 4 times. I mean, okay, so I mean, yeah, from its position till the beginning of the array, it's 3. But why would you rotate backwards? Why would you not just rotate forward? Is it still 3? Yeah, it's not. Okay, okay, what is this one? I'm assuming the rotations make it easier, make the time complexity easier to achieve, instead of just, because I think if you sort the array, then it becomes n log n. And then, I mean, if you just sort it, you just get the beginning. Right? If you do like, so if you go, okay. This one doesn't count though. So, nice, my camera just flipped. Okay. My gimbal died, so I'll use this camera for now until I try this. Anyways, yeah. So if you just sort the array, you grab the first value. That's what they want. They want the lowest value in the array. Yeah, it's n log n, so it's not what you're looking for. They want log n. So that's why we want to rotate it, because binary search can find it in login. So we can figure out a way to rotate it. Let's see. Okay, let's go back to the. I don't know if it's the font, but this is like horrible to look at. Is it the spacing around there? Okay. Oh, okay. That makes more sense. So it's already rotated. You see, I have to like read the question like 1,000 times. So you have an array, size n, it's sorted in ascending order, and it's rotated. That's why when I looked at the example, it didn't make sense. Because it doesn't look sorted. Well, it didn't look sorted to me, but so it's already sorted, but it's rotated. The rotation part is kind of weird. Okay, I should probably whiteboard this. I'm not going to count the other solution because it took n log n, and we want to do it in log n. So let's go to the whiteboard. Let me check if this gimbal charged so I can put the camera right. Okay, it did charge. I think we should be fine using it. Let's see. I charged it the other day and I guess it didn't charge all the way. Is that good? I think that's fine. Okay, let's continue. So I think this is we could perform binary search if we know where to place left and right pointers. As far as I'm aware, you can only do binary search on sorted arrays. It's already sorted, but it's out of place. I'm also assuming we can't make a copy of this. What's the space complexity they want us to do it at? It might be constant. We might just have to deal with the original array. I'm looking at the question. Yeah, we can't make a copy of it. Okay, sucks for us, but don't think it will work on. Do we have a left and right pointer and then mid? You know, normally we'd look at mid and then we'd determine if we wanted to move the left pointer to this side and then recalculate mid, or if we wanted to move the right pointer. But it's a little bit different here because left is not pointing to the correct location. It should be pointing at 1, which is, let's see, which would mean, I mean, can you use binary search on non-sorted? What's a different way to look at this? Okay, let's look at a hint. Hint 1. Yeah, I think we're missing one here. It should be like log n. Wait, I have it down here. Why wasn't it up here? It should be here too. Okay, they're named up there, but they're not here. Okay, we solved it in log n. Yeah, but it doesn't really matter. The poor worst. Yeah, I'm not log in. Like, there's nothing coming to my brain. Okay, let's look at a different hint. You know, brute force would have been a better solution than what I did, but whatever. Okay, we're considering the array. What about it? Rotate it twice. Okay, but okay, it has 2 segments from 3 to 4 and then 1 to 2. But finding the segments would give away the minimum. Anyways, let's see. On the right. search for this cut. Interesting. What is the cut? That the right is less than the left? I think that's the cut. Interesting. Okay. Let's see. What about mid? If we look at mid's neighbors, okay, coincidentally there we know. Let's grab a bigger one. I think they have a bigger example on here. Okay, yeah, let's use this one. Okay, we have a left pointer here. Mid, I think, will be here. Then we can compare mid's neighbors for the, and then look for the cut. So let's see. Okay, well, this one doesn't work. It's such a coincidence that mid was the cut. Oh wait, I have a better one. What about this one? Okay, in this first scenario, mid is min. And in this scenario, the right pointer is min. Sorry, not the right pointer. It's like it's wrong. It's mid minus 1 and then mid plus 1. So for this first one, food. Okay. For this first one, this also tells us if it's not true, if the case is that it's not true, then we know we're still in ascending order. Okay, same for this one, I think. It's for both of them, actually. So how do we move the pointers given this information? Because the split could either be to the left of min or the right of min. And if both of these are still the case, then we don't really know where to move. Look at the next sentence. Is we perform a binary search on the array with pointers L and R, which belong to two different sorted segments. For example, I think this is the array that they gave us earlier. Left and right. Mid is 2. Mid is 2. What are you talking? Okay, index 2. Says at least 2 of L, mid, and R will always be in the same sorted segment. Are they saying like at least 2 of the pointers will be in the sorted segment? Wait. Okay, so the left and the mid pointer are in the sorted segment, then num L should be less than num's mid. Okay, that makes sense. The min elements will be on the right part of mid and right pointer. Then num's mid should be less than num's right. And the min element will be in the left part. Okay, I think it's saying if we compare nums L nums mid, and if this is the case where nums L is less than nums mid, then the split should be from mid to right pointer. Wait, that doesn't fit their condition. That doesn't make sense. They're saying that the left and mid would be in the sorted segment if they're in the sorted segment. Okay, well, this condition is true, and then they're saying that the minimum element will be on the right part. So they're saying it should be here. That's not the case. I think I'm taking too long. I'm going to watch the video.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem, find minimum in a rotated sorted array. Binary search is going to run like this, a left pointer and a right pointer. If we ever get to a point where the entire array is sorted, we can just return the leftmost element, or at least consider this as being the minimum value. So let's try a binary search and see how it's going to be different than a regular binary search. Now, of course, we want to find the minimum value. We're going to initialize our left pointer here and our right pointer here. Basically, the current pointer situation means that we are considering this entire array to find the minimum. The minimum could be from anywhere in this array. And the result is going to be the minimum, and I'm going to keep track of that over here. Now, of course, one way we could do this problem is basically find the pivot, right? Find the position where, the elements are not in increasing order, right? From here to here, 3 to 4, they're in increasing order. From 4 to 5, they are in increasing order. From 1 to 2, they're also in increasing order. But from 5 to 1, they're in decreasing order. This is the pivot, right? So basically, this value is going to be the minimum, but I'm going to do it in a slightly different way where we don't necessarily have to, look exactly for the pivot. I'm going to take, left, right, take the half of them, get our middle pointer. Our middle is going to be over here at 5. So I'm going to consider as 5 being the minimum value we have seen so far, right? So our result is going to be 5. Now we have to ask ourselves, okay, this could have been the result, but now we don't want to, look at this value again. So the question becomes, are we going to search to the left or are we going to search to the right? Where are we going to find the minimum value? Where are we going to find a value that's even smaller than 5? Well, first consider this. Since we rotated the array, we have 2 portions of the array that are sorted, right? We have this portion of the array that's sorted, the left portion, right? And we have the right sorted portion of the array, which is also sorted. So the question is for us, with this middle pointer, at this value 5, are we currently in the left sorted portion or are we currently in the right sorted portion? Now, Now, if we are in the left sorted portion of the array, don't we want to search the right sorted portion? Reason being, if we rotated the array, the left portion is always going to have values that are greater than every value in the right sorted portion, right? Because when we rotate, right, suppose an array like this, we're taking the rightmost value, the largest value, and putting it over here, right? So we're taking larger values, putting them on the left side, right? So therefore the values on the right are going to be smaller now. So that's why it's always going to be that way. So if our middle pointer is currently in a value that's in the left sorted portion, then we want to search the right sorted portion because it has smaller values in it, right? So how can we know if we are in the left sorted portion? Well, like I said, every value in the right sorted portion is going to be smaller than every value in the left sorted portion. So one thing we can check is if the current middle value is greater than or equal to the value all the way at the left of our thing, right? Because the left value is going to be the smallest value. If the middle value is greater than or equal to the leftmost value, that means this middle value is a part of this left sorted portion. Right? In which case we want to search to the right. Now, if our middle pointer, suppose in this case we can see 5 is greater than or equal to 3. The reason we're doing greater than or equal is technically this middle pointer could actually be at the left position as well. That's one edge case. And in that case, we would also, this would be the left sorted portion. But suppose our middle pointer, instead of being at 5, was actually over here. It was at 1. What would our condition evaluate to that? Nums of middle would be 1. Is that greater than or equal to the left value, which is 3? It's not, right? Because the values in this right sorted portion are going to be smaller than the left sorted portion, in which case this would evaluate to false, right? If it's false, that means, if we're at a value that's in the right sorted portion, then we want to search to the left, right? Because in this case, the right, if our middle was at this, it makes sense that, okay, all the values to the right of it are going to be greater, so then we want to search to the left. But obviously these values are also greater, but that kind of doesn't illustrate the point, because what if our middle pointer was over here, right? Maybe we had some values over here. This is where our middle pointer is. We see 2. Okay, 2 could have been the minimum. Then we want to search to the left because we want to find even smaller values. Particularly, we would want to find this 1 that happens to be smaller, because we don't know where the pivot is. The pivot could be here, the pivot could be here, it could be anywhere. We just know we have to look to the left if we want to find smaller elements. If our middle pointer happens to be in the right sorted portion, then we want to search to the left. If our middle pointer is in the left sorted portion, then we want to search to the right. And I just showed you the condition we can use to detect that. So now I'm going to run through the example, and it'll probably make more sense. And by the way, the algorithm I'm describing only works on a rotated sorted array. If we ever got to a point where let's say our right pointer was over here, meaning that, this is our entire search range, then we could not do this algorithm. In this case, if we ever got to a portion of the array that's completely sorted, we would just take the leftmost value and see if it's smaller than our current result, and then we would stop the entire binary search. Okay, so now let's run through the example. These are the conditions that I talked about that we're going to be using. So our middle pointer is here. Let's check we checked that this might be the minimum. Now we're never going to look at this again. So now we're going to check, is this value greater than the value all the way to the left? Yes, it is. So we're going to search right. Since we're searching right, that means we're never going to search these values again, so we can cross them out. We're going to take our left pointer and shift it to mid plus 1. So our left pointer is now going to be over here. This is our new search range. And as you can see, this portion of the array is already in sorted order, right? How do we know that? Because the value at our right pointer is greater than the value at our left pointer. So that means that the array is entirely sorted, and then we can just take the leftmost value here, which is 1, see if it's smaller than our current result. Yes, it is. So then we can return 1 in this case. Now, just to kind of illustrate the opposite case, arbitrarily, I'm just going to say our middle pointer is actually going to be over here for some random reason. Let's just see how our binary search would work in that case. Well, we would take this middle value, say that it might be our result, so our result is going to initially be 1, and then we're going to run through these conditions. Is the middle value greater than or equal to the leftmost value? It's not, so we execute the else case, which basically means we're searching left, right? So we're going to take, this is not going to be considered again. We're going to take our right pointer, set it to mid minus 1, so our right pointer is going to be over here, and we're going to cross out 2 because it's never going to be searched, right? Because we shifted our pointer. This is our new search range. Once again, you can see that this range is sorted. Basically, the left value is smaller than the right value, so this is already sorted. We can take the leftmost value over here, see, is this smaller than our current result? It's not, so our result stays the same, and we don't have to search this entire portion because it's already sorted. So that's kind of the general idea of how this algorithm is going to work. It's pretty easy once you kind of figure out these two conditions. With that being said, we can jump into the code. Okay, so now let's get into
Maybe I should not have watched that in 2 times speed. so I get the video. So if the mid is greater than or equal to left, what am I missing in here? That's cheating, guys. To be fair, I did solve it prior to looking at the solution. Like, this was my solution prior. Just sorted it, returned the first value. I don't quite get it. Submissions. Okay, we're gonna use some local model to see, try to get a better understanding. I didn't quite understand the video. He kind of said something about, it had to do with the wrapping, the way the rotation works. I understand the divide part, like the increasing order and the rotations create the divide between section where the numbers are just increasing and then another section where they're also increasing, but there's a clear divide. There's a section between them where they're decreasing. What I don't understand is try one of this. What is this? Quen? Let's do that. Try to get a better understanding because I do not understand. Also, I just realized I commented this part out and it worked just fine, so you just have to continue to do that. This question 153. Let's see if Quen knows about Leetcode question 153. This thing takes forever though. Okay, we'll let it do its thing. And go back to the tree. What does it say? What's next? Okay, we did this one yesterday. This one today. Okay, another array rotation thing. That one was not my favorite question. Okay, still same setup. You have an array, it's rotated, and it's in ascending order. Cool. Okay, you're given a target, return the index of the target within nums. Okay, so now we have to find the target in the rotated array, or return -1. Okay, all the values are unique. Okay, did it finish? It's still thinking. Okay. We'll let it do that. What's this? Let's look at the solution. I guess it's just an extra step on here, right? So we're not looking for the min. We're looking for a target now. So I don't think we would. Okay, wait. Let's go to the correct question. We could take this. This is, my computer's gonna blow up. This thing's not liking this question. Not enough. Why is it criticizing the code? It's supposed to be explaining the code to me. Oh, brother, this thing stinks. Okay, well, we'll see what it says. I think it's like hallucinating right now. Okay, let's see. What did I copy? Another question. Was it done thinking? Nice. Is that its response? I think it is. This guy stinks. Get out of here. Useless. Let's try a different model. Get out of here. Eject that guy. Okay, we'll try this one. I just asked it to explain the solution. Apparently that was too much. Okay, let's try it again. Maybe it doesn't know what the question is. Okay, let's see. Okay, did it stop thinking or is it still? What does this mean? It used all the tokens. I think I could fix that. Maybe I should give it like 100,000 tokens. Wait, it supports up to 200,000? I think that's too much. I have to reload. Let's reload. We're gonna blow up my computer. Maybe I should do it with less tokens. 112. Go back to the question. it stopped because I ran out of tokens. Why does it work? Okay, we'll let it do this thing. I don't think I'm gonna solve this next question. It looks very familiar to the other one, but I think if I just copy and paste from the other solution, I didn't really learn much out of that. So I'm gonna try to understand the previous solution, because it also has to do with rotation. I don't quite understand the decision to search left or right. I think that part's weird. It barely made sense with finding the minimum. It for sure does not make sense with finding the right. I guess you would just do binary search on the laptop.